Good morning, students. One more important question which is repeated nearly 5 to 6 times in the mid examination from kinematics rectilinear motion. The problem goes like this: the acceleration of a particle along a straight line is given by a is equal to 4 minus t square divided by 9. If the particle is starting from zero velocity from a position x is equal to 0, then we need to find its velocity after 6 seconds and distance traveled in 6 seconds. So it is similar to the previous question where where I have differentiated the equation to get the velocity as well as acceleration. Now from acceleration we need to get the velocity, and from the velocity we need to get the displacement. So the steps are very simple. See, for example, we have got an acceleration here, right? Acceleration A can be written as dv by dt, that is rate of change of velocity with respect to time, dv by dt. Now when you integrate the velocity with respect to time, integral of acceleration, you will get the velocity, and again when you are integrating velocity with respect to the time, right, you will be getting the displacement. Okay, whatever the acceleration which is given to us, a is equal to 4 minus t square by 9. This is the first equation which is representing acceleration. Now we know that acceleration is dv by dt. So it can be written as 4 minus t square divided by 9. Now just cross multiplying, we will get dv, which is equal to 4 minus t square divided by 9 multiplied by dt. dv is equal to 4 minus t square divided by 9 multiplied by dt. Now I'm integrating this particular thing, integral of dv from 0 to v, that is equal to integral of 4 minus t square by 9 dt from 0 to t. You will get v is equal to 4t minus t cube by 27. Now this is velocity. Let us call this one as second equation, which is representing velocity. Now we know that velocity v is equal to dx by dt. Now dx by dt, it is equal to the same equation again, 4t minus t cube by 27. Across multiplying, we'll get dx is equal to 4t minus t cube by 27 multiplied by dt. Now whatever the equation you are seeing here, it is differential dx, right? That means whatever the displacement in middle of the moment we are considering. Now integrating the same thing again, integral of dx from 0 to x, that is equal to integral of 0 to t 4t minus t cube by 27 dt. Now from this one we will get dx, or simply x, whatever the integral we are considering here, that is x is equal to 2t square minus t to the power 4 by 108. This is the most important thing for us, as well as the velocity equation, whatever the velocity equation we got it. Now let us call this one as the third equation, which is representing the displacement. Now in the question they have asked us to determine the velocity after 6 seconds. So velocity v is equal to 4 times t minus t cube by 27. This is actually the second equation. Velocity at time t is equal to 6 seconds. Just substituting the value of t is equal to 6 here, 4 times 6 minus 6 cube by 27, you'll get the value as 16 meters per second. Similarly, distance traveled, x, when t is equal to 6 seconds, that is equal to 2t square minus t to the power 4 by 108. This equation, this particular equation. Now substituting the value of x, t is equal to 6 seconds here. 2 into 6 square minus 6 to the power 4 divided by 108. We'll get displacement or distance traveled x, which is equal to 60 meters. Now these are the required answers. Right. Thank you.